today in this example, a DC shunt generator where a belt-driven 60 kilowatts shunt generator running at 500 RPM is applying full load to a bus bar at 200 voltage. At what speed will it run if the belt breaks and the machine runs as a motor, taking 5 kilowatts from the bus bar? Okay, first, let's write the given. We have 60 kilowatts as output of the generator. So output of the and running at 500 rpm, also the speed of the generator 500 rpm. So speed as n g, since it is the speed for the generator. Also a bus bar of 200 volts. When we say bus bar, it is a infinite connection of generators and motors. That's why it must be a constant. Okay? At what speed will it run if the belt breaks, if it becomes a motor taking 5 kilowatt from the bus bar? The armature and the field resistance, we have RF, RF, RA, and the Vbrush, or the contact voltage of the brush. RF of 100 ohms and 0.1 ohms for the armature resistance, and the contact drop voltage of the brush is 2 volts. N of the motor, the speed of the motor. Okay, let's draw the circuit. So at first it is as generator. Positive going to the bus bar and the negative. Generator IL, IA, and ISH. Then as motor, RSH, RA, and EM as motor. but the direction of current is going into armature, so IL, IA, and ISH. So we have to find the we have NG here and we have NM. The question is, what is the speed of the motor? So step 1, uh, so IA is equal to ISH plus IL. So we have ISH is 200 voltage divided by 100 ohm resistor plus IL is 60 kilowatts, so 60,000 watts divided by 200 volts. So we have IA of 302 amperes. Okay, so we have 302 amperes. We can now get the EG, and we have the VL from positive to negative, IA and RA. We will get the EG. Okay, for the induced voltage of the generator, we have EG is equal to VL, or the busbar voltage, plus IARA plus the Vbrush, or the voltage drop at the brushes. So formula, we have 200 plus IA of 302, 302 amps times RA is 0.1 ohm plus VB of 2 volts. Okay, so EG is 232.2 voltage. Okay, step 2, we have to find the EM, or the induced voltage of the motor. Since this is equal, their difference is the direction of current. As generator, the EG is supplying the bus bar, so it is supplying the bus bar, while as motor, the bus bar, or the VL, now is supplying the motor. As motor, 0 minus EM from the mesh here. So we have 0 is equal to VL plus the VL minus IARA minus EM, and minus we have the contact brush contact voltage drop. Okay, so formula is EM. We find EM. EM is equal to V minus IARA minus VB. We have 200 minus So IAR is 5,000, which is, as motor it draws 5 kilowatt, mile over 200 volts times 0.1 ohms minus 2 volts. So we have 195.5 volts. So step 3, we have our step 3. Now we have the EG and also the EM. What we are going to find is the RPM. So step 3, let's write the formula of the RPM. So EG is equal to ZPN flux over 60A, or EG is equal to K flux N, where flux and K is not given, so equal to K, we have EG is equal to KN and G. Therefore, EG over NG is equal to K. And also, sa motor, we have EM over NM is equal to K. K and K is equals. So we have EG over NG is equal to EM over NM. So we have NM is equal to EM times NG over EG. So we have EM 195.5 volts times NG. What is the speed of the generator? 500 RPM. And also the EG, voltage of the generator, which is 232.2 voltage. So cancel. What remains is the RPM. So we have NM is equal to 421 421 R. Okay, that's all. So we have the answer of 421 RPM.